video is to help out with the lesson in Edgenuity dilations. So dilations, what they are is it's taking a shape and it either makes the shape bigger, which is an enlargement, or it'll make the shape smaller, which is a reduction. So if your scale factor, I'll just put scale factor, is greater than 1, you have an enlargement. So let's say your scale factor is 2. Your new shape will be twice as big. Let's say that your scale factor is between 0 and 1. So things like a half, 0.3, 0.75. This would be a reduction. For example, if your scale factor was a half, your shape would be half as big. So to figure out what your scale factor is, you do the prime distance over the original distance. So for example, here, just looking at here, if I don't have enough information here, but if I did, the distance from, remember to denote the prime, like let's say it has a little apostrophe on it. So you do that distance over the original distance that has no apostrophe on it. So here I would do the P to H prime's distance on top, the prime distance, over the original P to H distance. So I'm going to skip this example for 1 second. We're going to come back to it. So like here, what is the scale factor of this shape? So again, you're going to do the prime distance over the original distance. So the distance from C to the prime, you have to add that whole thing. So 4 plus 16 is 20. Over C to the original A was only 4. So if I simplify that, 20 divided by 4 is 5. This scale factor is 5. This shape is, this part here is going to be 5 times as big. So let's look at this one. It says, what is the scale factor? So again, we're going to do the prime distance over the original distance. So the distance from A, we have it on this ray here. The distance from A to V prime is 3.2. The distance from A to our original is that whole thing there, so it's 3.2 plus the 4.8. So that's going to give us 3.2 over 8. Go ahead and simplify it. Let's see, 3.2 divided by 8 is 0.4. So this is an example. Okay, so let's look at the two values. This scale factor is 0.4. This scale factor was 5. See if you can decide which is an enlargement and which is a reduction. Bigger than 1? Between 0 and 1. And you can tell, I mean, this shape is the original, it got smaller. This segment was the original, it got bigger. So let's look at the one from the other page. So on this one, it says the scale factor is 1/6. What's the length of PG? So I'm just going to put an X there. That's what we're trying to figure out, that distance there. So we're going to use the scale factor and a proportion to help us out. So the scale factor is 1/6. So if you think about it, when we did scale factor, remember it's prime over original. So this is 1/6. So I can take my prime distance here of 0.5 and put it over my original, excuse me, which we're trying to figure out. So the scale factor, prime over original, equals prime length over original length. And then from there, when you have a proportion like this, you can just cross multiply. So on the left, I would have, well, it does it right, 1 times x equals 6 times 0.5. So x equals 3. So PG, that distance here has to be 3. Okay, last one. It says, what is YT? So first I'm going to figure out what our scale factor is. So this one we have information for both parts. So our prime distance, t to x prime, is 6. And our original distance, t to x, remember you have to add them up because it's both of them together, so 2 plus 6 is 8. So if I simplify the top and bottom by dividing by 2, our scale factor is 3/4. So now I'm going to use that to set up a proportion just like we done on the last one. prime over original in scale factor will equal prime distance over original distance. I'll just put an X there for the lengths there. So if I cross multiply, 3 times X equals 4 times 9. Divide by 3. So that distance YT was 12.